Hi everybody, in this lesson we're going to take our first step into learning the Spring Boot framework for creating Java web applications. And so this lesson is going to focus on a couple of things. First, we're going to talk about what Spring Boot is and what it does for us and why we're using it. And then we're also going to start learning about controllers and how to build controllers to handle web requests within Spring Boot. Okay, so first let's review the MVC design pattern. So I use that phrase design pattern. That's a common one in software development. You'll hear it more and more as you gain more experience. A design pattern is an approach to solving a common software problem. And so it's not something that's specific to a programming language. It's not something that is specific to a specific framework. It's more of an abstract approach that can be applied across different languages and across different frameworks. So MVC is a design pattern. It's something we've seen already. So we built Python web applications in an MVC way, and we're going to build Spring, or Java web applications rather, using Spring in an MVC way as well. Okay, so MVC, that approach, this abstract idea of how to solve this problem, is something that you've seen before. We're just applying this pattern in a different language and a different framework. So let's review what the three components of MVC are. The M stands for models. And the models are what are often referred to as our business objects. In other words, they are the objects that represent data that is part of the core functionality of our program from the standpoint of what is your program about, right? So if you have a blog application, your model objects would be the users and the blog posts, and you might have other model objects such as categories or tags or comments if people were able to comment on the blog posts. So those are the essential things that your program is about. And these should be, the design of your models should in a lot of ways be independent from the framework that you're using. We also have the views. So the views are the way that we display data to the user via an interface. And so typically for us, views are going to be web pages or templates that generate web pages rather. And I want you to know that views in this idea in the MVC world, views do not have to be web pages. So the MVC pattern can be applied to desktop applications. It can be applied to mobile applications, and in fact often is. And in those worlds, views are going to be the windows on your desktop or the screen on your phone. So views are just abstractly the way that we display data to the user and provide them an interface for interacting with our application. Controllers are where we're going to start today. And they're kind of the traffic cops. They're kind of in the middle of the MVC world, connecting the model and the views together. And they're the ones that are really kind of the heart of the application. We can't have a web application if we don't have controllers. Controllers are the particular pieces that that receive and decide how to handle HTTP requests. So we can build a web application here without views and without a model, but we really can't do it without a controller. And so we'll see exactly an example of that today. Here's a diagram illustrating the flow, or one way to describe the flow of an MVC application. So down at the bottom, we have a web browser. And so the green arrow is a web browser making a request to the web server. And the framework and the application server that is running our web application is going to be what actually receives that request. So the request isn't going to come directly into a controller. It's going to be received by a web application server, and then there will be some mechanism for figuring out which controller should be called to handle the request. And so we'll talk about routing, which is a big part of that in a future lesson, right? But there's some level of machinery there that is going to be a part of the framework and part of the application server that we're not going to really get into the guts of, other than we know that it's there and we have some basic idea of how it's supposed to work. So web request comes through the web application server. It gets routed to a specific controller, and that's the center of our picture there. So the controller will then decide, based on the request, what it should do. So generally, that's going to involve going to the model and looking up data. A model often has a database behind it, although it doesn't have to. And it's going to go to the model, say, look up some data or add data to the model. Once it's done that, it will then present a result of those actions to the user. So again, if you like specific analogies, think of a request to create a new blog post. The controller would receive that request. It would understand that it was given a title and a blog post body and the user that wrote the post, and it would use that information to create a new blog post object that would then put in the database via the model. And then once it was done with that, it might display the post that it created to the user through the view. Okay, so this is the general flow. We'll revisit this diagram as we introduce each component of MVC in turn to understand how each new component is going to be adding to the picture. Today, you can just imagine taking out the model in the database and taking out the view, and that will be what our application looks like at the end of today. So that's the idea behind MVC in an abstract way from the design pattern perspective. Let's talk a little bit about Spring Boot. Spring Boot is the framework we're going to use to build Java web applications that implement the MVC pattern. Spring Boot is one portion of a larger framework, a very large framework called Spring. Okay, Spring's been around for a while. I think something like 15 years or so, roughly. The early 2000s is when Spring began development. And Spring provides a lot of different types of functionality for a lot of different types of software applications. We're going to focus again on one small piece of it. Spring MVC is a module within Spring that allows you to create web applications that follow the MVC pattern. So Spring MVC itself is one portion of the larger Spring framework. And then further, Spring Boot is an extension of Spring MVC. So that means that Spring Boot is essentially a particular version of Spring MVC that has some sort of pieces customized. In particular, Spring Boot is, it follows what's called convention over configuration. So this approach, convention over configuration, says that when we're going to set up a framework, let's go ahead and make up, as the designers of the framework were thinking about this, they said, let's go ahead and put a bunch of default types of behaviors in place. So the user doesn't have to configure everything from the start if they want to use it. They'll be able to configure ways to override the default behaviors later on if they want to, but we're going to go ahead and put a bunch of default settings in place so that it's as easy as possible for people to get up and running with this particular framework. And so as we get started with Spring Boot, one of the reasons we're using Spring Boot and not Spring MVC in particular is that it does have this approach, and it is going to allow us to get up and running a lot more quickly. A few of the sort of conventions that we don't have to configure within Spring Boot, let's explore a few of those. The first is that we don't have to worry about the web server that's going to run our Java application. So Spring Boot provides an embedded application server that will run our Java apps. It's called Tomcat. If you're interested in learning more about that, I encourage you to go look up Tomcat on its official page or on Wikipedia. We're not going to really get into the mechanics of what Tomcat does, other than from time to time to focus on the fact that it's wrapping our application and it's part of that machinery that's going to feed our application requests. Spring Boot also provides lots of default settings and locations for things. So we're going to be able to just sort of rely on the fact that certain things are kind of set up for us, and if we put certain files in the right place, they'll be found without having to configure every single path or every single setting. And furthermore, when we do want to configure our application, we're going to be able to do it without using XML. So traditionally, Spring applications use XML-based configuration in a very heavy way. And XML is a file format that looks kind of like HTML. It's kind of like a more general version of HTML. And if you look at Spring applications out in the wild, you'll often see various XML files as part of those applications, and those are what are used to configure the details of the application. In our case with Spring Boot, we will not have to touch XML configuration files at all, which is great. We'll be able to configure applications within the code itself. So just so you can have a picture of what Spring is as a whole, I provided this image from the spring.io website, and this kind of gives you one perspective on all of the different modules that make up Spring. And so we're going to be working over here, right in this little area right there of the web module. There's all this other stuff here that we're really not going to look at all. So there are pieces that we'll use. For example, we'll use dependency injection for sure. We'll use some data access machinery, and those things kind of intersect with other components, but we're really using them. We're not using them as our core framework. And there are a lot of things that we really won't touch that are across the Spring environment. So just to show you, when we talk about Spring and then we talk about Spring Boot, to see kind of how those are related, you can see from this picture that Spring Boot is one small portion of Spring as a whole. Okay, so let's go ahead and get started and build our first Spring Boot application. I'm going to go ahead and exit out of my slideshow here, and we will just start at the desktop. Open a browser and go to start.spring.io. Okay, this is a nice little handy web tool that Spring's provided us that will generate just the minimal application file structure that we need to make a Spring Boot project. So to do this first project, we're going to need to configure a few of these options here. Let's open up this first dropdown and select Gradle project. And we'll talk more about what Gradle means and what Maven is, how those two are different, and what they do for us later on. This default option is fine. Under project metadata, let's go ahead and add our top-level package name. Again, I'm going to use org.launchcode. If you have a domain that you use for your personal work, you can do that. Convention is the top-level domain first, and then the regular part of the domain. So in other words, it's backwards. And for the artifact, this should be really the name of our project. So I'm going to call this Hello Spring. And convention here is that your artifact name is all lowercase with dashes separating the words. Okay, so Gradle is a tool that's going to help manage the external dependencies for our project. We can go ahead and specify any dependencies that we know we're going to want to use right here within our project. So we're going to add a few. Let's go ahead and add web. Let's go ahead and add dev tools. And let's go ahead and add time leaf. Okay, so there are ways to add these dependencies later on if you forget to do this, but right now, if we know we're going to use something, we might as well add it to our starter project. Hit generate project, and you'll get a download of a zip file that contains the code. All right, so I'm going to go here to my downloads folder, and I'm going to unzip this. And now what I'm going to do is I'm going to move this to a location where I can actually work on it more reasonably. So the details of where you're storing this stuff and how to get there based on your operating system are a little bit different, but you just want to move the unzipped project folder out of your downloads folder to a more reasonable place. So I'm just going to move it, I'm just going to move it to my dev folder. Okay, great. So now I'm going to fire up IntelliJ. And once this entry window opens, this welcome modal, I'm going to select import project. All right, we don't want to create a new project because that would be creating it from scratch without any existing files. We already have this this project we've been working on, or this project structure we've been given, and so we're just going to want to import that. So select import, then browse to the place where you put that stuff. Let's see, Hello Spring. There it is. And we're going to, as before, be presented with a lot of different options here. Go ahead and say create project from existing sources. Hit next. Project name is fine. It's going to pull that from the artifact name, or the directory name rather, from your project. And here, IntelliJ is telling us that it's found a couple of directories that contain source code. And do we want to go ahead and mark those directories as containing source code so that IntelliJ can build them for us, which we certainly do. So make sure you leave these checked. It's also found some libraries as part of our project. In particular, there's what's called the Gradle wrapper, which provides the Gradle functionality to our project as part of that. We do indeed want to make sure that's part of our project. And here you can confirm that these should be modules as well. Again, all of this is default setting stuff. And once we finish, IntelliJ will furrow its brow, and spin its cogs. And you will likely see this unlinked Gradle project. Go ahead and say import Gradle project. And when you get this dialog, check the use auto import and leave everything else as it is. Okay, so here's our project. Here's what we've been given. All right. In particular, we've been given a gitignore file. We can look at that. That's going to contain some basic stuff that Spring expects us to not want to put in our repository. In particular, here's IDE related files. Here's the build, which is our compiled code. The Gradle jar and the .gradle directory, which stores information about the Gradle program. All this stuff. So that's just good to know that that's there. We're not going to have to add manually these things to our gitignore file as we've done in the past. And there we go. So let's talk a little bit about Gradle. So I don't want to get too far into this because we're going to talk about Gradle and how we're using it over time and introduce the concepts when they're most relevant to what we're learning otherwise. Gradle is a tool. It's a package that performs a lot of things related to working with and building and deploying software applications in Java. And so if you open up this build.gradle file, you'll see a bunch of stuff. This is Gradle's syntax, and we'll get in here and tweak some things from time to time. You don't need to know what everything does here, or what everything in here does. What we do need to know is that Gradle is going to manage, for us, the first thing to know is Gradle is going to manage external dependencies of our project. So if you look down at the bottom, you see this little data structure called dependencies. And in particular, recall that when we generated the project from the start.spring.io website, we specified that we wanted web, DevTools, and TimeLeaf as part of our project, right? That's what we were specifying. We were specifying that these were external libraries that we want to be part of our project. So Gradle then knows about these, and when we go to build our project, Gradle will fetch them from a repository out on the internet and bring them in for us, okay? And make them part of our application. In particular, it goes to what's called the Maven Central Repository. And so the Maven Central Repository is just the centralized place where software developers can make their packages available for other users so that people that are using tools like Gradle or Maven can easily fetch them and make them part of their projects. Okay, so let's see. So that's all we're going to really need to know about Gradle for now, is that it helps us manage external dependencies. There are some other things that it does for us as well that we'll look at later on. So, okay, let's go ahead and just see that we have minimal code here to actually start up a web application, okay? So to do that, to start our application, I'm going to go over here to the right-hand pane. If you don't see this, you need to look down at the bottom left corner, go ahead and click the little icon, and then you'll see these pane toggle buttons. Open up the Gradle pane, and if we go to tasks, these are the various tasks that Gradle can do for us. Under the application folder, we see that we can boot run. This is what's going to run our application. Go ahead and just double click on that. By double clicking, that will execute that task, and our Spring Boot application will go ahead and start up. So once Spring Boot finishes starting up, the last message you'll see here that you'll get very familiar with is this one: started Hello Spring application in 12.503 seconds. Obviously, these things will be a little bit different depending on the application you're working with and how long it takes to start up on your machine. But this startup message tells you that Spring Boot started up successfully. If there was some problem with the configuration of your application or with your source code, you'll see an error message or a stack trace within this window, and then you'll have to go figure that out. But if everything starts up successfully, this is the message you'll see. And look at the second to last message rather. This says Tomcat started on port 8080. So this is telling us, I mentioned before that Tomcat is the embedded web server that our Java applications will run inside of. And so that is telling us that Tomcat is listening for requests on local port 8080. So let's just go ahead and go to a web browser and browse to localhost colon 8080. And you should see an error message here. Okay, so that's not too surprising. We haven't actually added any real code to our application. This is just telling us that while our application is running, there's basically nothing sitting there listening at its root path. So we're going to go ahead and go back now and add our first controller to listen for web requests. So let's go ahead and go back here. You can close this Gradle pane for now. You can stop the application by hitting the stop button right here, or it's also up at the top right. All right, so let's go ahead and look at the source code that we're provided. If you go to the source directory, there are two subdirectories, main and test. So test is where you would put any tests for your application, which we're not going to get into now. But if you go to main and expand that, you'll see two folders within main. There is the Java folder and there is the resources folder. The resources folder is where we'll put files that are non-Java code that are needed by our application. So things like templates or CSS files or JavaScript files, those will eventually go in the resources folder, and we'll cover those in future lessons. Let's open up the Java folder here. And if you look in the Java folder, you'll see that we have this Hello Spring application. So go ahead and open that up. And if you see these red messages, go ahead and just, Alt-Enter or click on the context menu to add the corresponding library to the class path. And those will just go right away. That's just pulling in those classes into the context of where you're working on your code specifically. So you'll only have to do that the first time that you're working with Spring, potentially. So within this application, if you expand the main method, you'll see that there's just one line within the main method, and it says spring application.run. So this main method, when we run our application, we ran it a minute ago, that is the main method that was actually run within the Tomcat web container server. So it's only one line of code. There are other things you could do in this section, but we won't specifically be working with this method or with very much configuration in this area, at least for a while. So go ahead and close that out. So the next thing I want to do is actually show you how to add a controller to your application in order to get it to respond to web requests. Okay, so within LaunchCode, org.launchcode, go ahead and right click and let's create a new package. We'll call this controllers. And within that controllers, we'll add a new class. I'm going to call this Hello Controller. And in both situations, I'm following Java naming conventions. Okay, so this is a class. It's just an empty class right now, and it's in our controllers folder. We have to do a little bit more work in order to let Spring know that we want this class to function as a controller. So the first thing we have to do is right above the class, start a new line and use the @ symbol and then enter the word controller capitalized. You'll have to, again, add the proper class as an import or to your class path. So this is an example of what's called an annotation. Annotations in Java can be used in different places. Most often we'll use them above a class definition or above a method definition, although they can be used in lots of other places as well. And you can think of annotations as adding sort of metadata or configuration type data about the code that you're writing. So that's not part of your code, but it's information that helps the framework you're in or the Java runtime understand a little bit more about how that code is supposed to work. Okay, so let's go into the class itself. So we've specified that this is going to be a controller. We want to write just a simple hello world message that can be returned from a basic method within our controller. So let's create a new public method that returns a string. Okay, and I'm going to call this index because it's going to be just the index page, the main page of my application. And I just want to return the string hello world. Okay, now there's a little bit more we have to do here. The first thing we have to do is we have to specify which route or which path corresponds to this controller. So let's use the request mapping annotation. This is something you'll use on every every controller method that you want to respond to a request, we'll get the request wrapper annotation, and we can say value equals, and I'm just going to leave that empty. Sorry, request mapping. Chose the wrong selection there from the context menu. So request mapping is the annotation we want to use, and value will specify the path that should be mapped to this controller method, okay? So that will allow the root of our site to be mapped to this controller method, and we'll simply return hello world. There's one more thing we need to do, which is to say that we want this to be returned as plain text. So normally within a Spring Boot controller, it's set up to sort of work with templates, and so we'll pretty quickly get away from returning plain text. But in order to return plain text from a controller method now, we need to add this response body annotation. So we'll do this for the next couple of lessons, but then we'll quickly move away to templates in future classes. Okay, so let's go ahead and start our application and see how it goes. So I came back over here to the Gradle menu, but once you've started it, you'll see this this run configuration show up here, and you'll be able to just hit the play button again and again rather than going to the Gradle menu each time to start your Spring Boot application. All right, we're fully loaded. Let's go ahead and bounce over to our browser and go to localhost :8080. And there we go. We have our message, hello world, returned as plain text there in the browser. Okay, so the next thing I want to do is I want to just show you how to add a controller at a path that isn't the root path. Okay, so I'm going to go ahead and make a second controller, public string. I'm going to call this one goodbye because it's going to just say goodbye, just a different, kind of a somewhat arbitrary message, but I just wanted to say something different so we can tell that this is a different controller. All right, so that's all the complication my method needs. Let me just kill my server right here since we're going to need to restart it anyway. That's all the code that my controller method needs. I still need to add these annotations though. And I'm going to set the value here to be something non-trivial. I'm going to set it to be goodbye. Okay. And then I still need the response body because we still are not using templates. Okay, so let's start our application up again. And now this new method should be reachable by using /goodbye. And there we go. There it is. So that's how we can set up a controller and controller methods to respond to requests. And there's some more details about how to configure the paths that these handlers are set up to respond to. We'll look at more what's called, in the topic of routing. We'll look at that in our next lesson. But in this lesson, we kind of explored how to set up request mappings, how to set up a controller class, and then how to return plain text from a controller to the browser, in addition to just getting comfortable with setting up a new Spring Boot project and running it from within IntelliJ.